and welcome back to Algebra 1. Our goal for today is to continue working with our power rules to help us simplify expressions, and more specifically, rules 1, 2, and 3 all jumbled up. Alright, so yesterday we looked at some of these mixtures of rules, dealing with rules 1, 2, and 3. So my suggestion is I'm always going to start by looking for this rule number 3. That's where I would start. And I would say, all right, if inside of here is multiplication, right, like a times here and a times here, then I can take this exponent and I could share it to these individual items on the inside. However, if any of these items on the inside have a power already, then while I'm sharing, I'm doing a mixture of rule 3 with rule 2 of when I share a power to a power, I have to multiply those two. All right, so it's kind of like I'm doing a 3 with a 2 at the same time. I always want to start there first because removing the parentheses would automatically start to make the problem look a little bit more basic and more simplified. All right, once we do that, we've done our 2s that might, or sorry, our 3s that might result in having to use rule 2 at the same time. Then I should be left with stuff that looks like this. One big string of multiplication where I'm looking for rule number 1 where I would say, do I have any bases that match that I can put together? Or do I have any that are just numbers that are, it's one big multiply that I can put together? And that should get you to your simplified version. So last couple from today, we did the first 4 yesterday. So last 2. All right, we have an a times c times f squared to the 3rd times a to the 3rd, b to the 4th squared. Now, there might be a couple things you want to do here to sort of help yourself set up the problem. These two are side by side. That's a multiplication. So when the parentheses disappear, we still have to account for there's a multiply between the first set of parentheses stuff being times with the back set of parentheses stuff. And then inside of here, these are all next to each other. They're all multiplies. Now, yesterday, I saw people thinking that this exponent of 2 went with all of this stuff. So I'm going to add to our picture today. This is really an a to the 1st. This is a c to the 1st. And this exponent of 2 just goes on that variable of f, right? If it's not directly touching that item, it doesn't go with it, right? So a to the 1st times c to the 1st times f to the 2nd is what's really inside of there when I go to share that exponent of 3. Same thing in here. This exponent of 3 only goes with the a. This exponent of 4 only goes with the b. And the exponent of 2 goes with the whole thing, so be careful. So now, inside of both of these, we have all multiplication. So we could take our exponent and we can share. And when we take that exponent and share, if it's being shared to something that already has an exponent, and now that I put these ones in here, they all technically have an exponent on them. So we're doing rule number 2 at the same time, where I'm taking a power to a power when I'm doing that share. All right, when we take this and we share it to something that has a power, it's times. We now have a to the 1st, which is what was there, times 3. Now, yesterday I was just calling that a to the 3rd, but again, I saw mistakes of then people were taking this exponent that was in there and attaching it to multiple items, so be careful. Our next one, again, I'm sharing this 3 to something that already technically has an exponent of 1. So c to the 1 times 3 times our f to the 2 times 3. All right, back here, this is multiply, so we can take this and share it to both items. When we go power to power, it's a multiply. So this is an a to the 3 times 2 and a b to the 4 times 2. All right, let's go through. Let's simplify all our exponents, and then we'll look for other rules. This would be an a to the 3rd. This would be a c to the 3rd. This would become an f now to the 6th. This would become an a to the 6th power, and this would become a b to the 8th. All right, we've gotten rid of our rules 3 and 2 by sharing, and then while we're sharing power to power, we're multiplying. And now I have all multiplication left. So from this point on, I'm only adding up exponents. Right? I got to keep the multiply part and the added up part kind of separate from one another. So I'm looking for bases that are the same, and I can simplify those by adding up their powers. All right, so this is a to the 3rd. If I have any other base here that's also an a, I can take their powers or their exponents and add them up, which we do right here, another a to the 6. We have an a to the 3 plus 6. That would eliminate both of these. All right, we have this c to the third. I scroll through and I say, well, there's no other c's, so this would just be a c to the third step. All right, we have this f to the sixth. Again, we have no other f, so we would say this is just saying is a variable f to the sixth. And this b, again, doesn't have any other b's in the problem. It would stay as a b to the eighth. But if there were other c's, f's, and b's, we would do the same thing we did with our variable a by adding up their exponents, all on this step. All right, since there's going to be no other rules here to perform, we're going to take the whole thing and put it together as one big simplified thing. All right, so we now have an a to the ninth, a c to the third, an f to the sixth, b to the eighth. Now, I could have this in any order. The b to the eighth could have been in the front, the c to the third with the f to the sixth behind it, right? They could be jumbled however you want. However, the a has to have an exponent of 9, the c would have to have the exponent of 3, the f has to have the exponent of 6, and the b would have to have the exponent of 8. Good final simplified version. All right, last one. And this looks really, really simple, but it's actually more complex than it looks when we really think about what's in the problem. So negative m to the fifth, a negative m to the second, and a negative m that's got what looks like no power, but please remember that's a 1. All right, these are all times out here in between, so I'm going to add that to the picture. And these negative signs really mean there's a negative 1 times inside of here, right? Negative 1 times, and a negative 1 times. All right, so inside each set of parentheses is a multiplication, so I can take the power and share. If I'm sharing something that from the power outside to something that has a power, we have to multiply. In this case, nothing on the inside has a power other than 1, so we're just going to share. We're using rule number 3. So this gets that, right, that. All right, so negative 1 now is to the fifth. And I'm going to add in, I have a negative number with an exponent. So remember, I want it all together when I type in my calculator. And then now we still have this m to the fifth. All right, same thing here. We're sharing the exponent of 2. We have a negative 1 that's going to be squared times our m squared. And since our base here again is negative, we want it all together. We have to type it that way in our calculator to make sure we get the right result. And then back here, again, a negative 1 to the first, so just negative 1. Or I could put the 1 there, it means the same thing. And then just an m, or an m to the first would look like that. All right, let's do some simplifying. Negative 1 to the fifth. If I don't include the parentheses, I'm going to get a wrong result. So negative 1 to the fifth is negative 1. And to the fifth here, this negative 1 squared is a 1. We have this m squared. And then this negative 1 to the first is still just a negative 1. And we've done all our numbers of the problem. And then from here, let's put together everything we can put together. All our numbers can get multiplied. So negative 1 times 1 is a negative 1. And then a negative 1 times negative 1 would just give us a positive 1. All right, so we're like that, positive 1. And now all these m's are the same base, so we can simplify by adding up their exponents. Don't forget this m by itself is an exponent of 1 that has to get added into our total. So we have m to the 5 plus 2. Don't forget there's 1 more back here. All right, and now we can push everything together. 1 times m to the 5 plus 2 plus 1. 5 plus 2, 7 plus 1 more, 8. So m to the 8th would be our most simplified, most basic way to write this problem. Or I could technically put 1m to the 8th. All right, just doing it like this as m to the 8th is a more basic, simplified way to write it, but I wouldn't be wrong to include the 1 as our coefficient out front. All right, I hope that helps you attack your work for today. See you guys later.